Hey everybody, it's Mr. Cassandra here. I'm going to cover chapter 7.2 today. We're going to go over the notes and then the examples all in one video. It's probably going to be about 15 minutes long, the video, but it's going to be well worth it because I'm going to go over all of the example problems. I try and keep these videos short, but I also don't want to rush things because I know some people really depend on these lessons to be very thorough and answer the questions. So that way you can do your homework and feel confident about it. So here we go. First thing I want you to recall that there were 3 rules in chapter 7.1. In a couple of problems, these rules are going to come up again. And in the next chapter, we're going to kind of put all the 3 sections together. And, there's a lot of steps to some of these problems and multiple rules being applied. So I just want you to remember that in chapter 7.1, we had the rules that involved multiplying exponents with the same base, where you add the exponents. For example, if you have negative 3 to the 4th power times negative 3 to the 7th power, you would add the exponents because they're the same base and you're multiplying. So this would be negative 3 to the 11th power. The other rule we learned in that chapter is when you have a base raised to a power and that's being raised to a power. So I call that power to a power. So when you do that, you multiply the 2 powers together. So you would have x to the, or the base to the a times b. So for example, if I had negative 3 to the 4th power and I'm raising that whole thing to the 7th power, that would be negative 3 to the 4 times 7, or 28. And the last rule is if you have a product, 2 things being multiplied together, and they don't put the dot there in the problem, they just put them next to each other. Whenever they're next to each other, that means multiply. I put the dot there just to remind you to separate them because you're going to be doing this raised to that power and this raised to that power. Okay, and then you would apply the previous rule. So there are going to be 2 new rules in chapter 7.2, and instead of multiplying with the same base, we are now going to be doing a fraction, and a fraction means, if you actually draw a line and a dot for the numerator and a dot for the denominator, a fraction means divide. So I'm dividing x to the 8th divided by x to the 8th divided by x to the 3rd. So the long way of doing it, which I do not want you to do, but I'm just showing you how it works, is you expand it out. So you would have x times itself 8 times, and then you would have x times itself 3 times. And every x over x is 1, because x over x is 1, x over x is 1, x over x is 1. So 3 of the x's in the numerator, 3 of the x's in the denominator are canceling with 3 of the x's in the numerator. And when you get 1 times anything, of course, is itself. So now I've got x times x times x times x times x. So there are 5 of them left. So 3 of them cancel from the 8 here. That's why it's x to the 5th. So the rule is that you take the exponents and subtract them. So for our example, if I have 8 to the x to the 8th power, that's like 3 times I've said that now, over x to the 3rd power, you subtract the exponents and it has the same base. So that's the rule, that's the first rule of 7.2. The second rule of chapter 7.2 is if you have a fraction, they call it a quotient, and they say it's a quotient raised to a power. So just like with a product raised to a power, where you have to raise each of those things to that power, you're going to raise the numerator to that power and the denominator to that power. So it's really, really easy. Here's an example, and this is the long way of doing it, which I'm not going to accept because we're not doing it the long way. I'm just showing you the long way to show you why it works. So if I have 3 to the 4th power, 3 over 4 raised to the 5th power, that means 3/4 times itself 5 times. So 3/4 times 3/4 times 3/4, etc., 5 times. Now, what happens when you multiply fractions? Well, some people accidentally cross multiply. That's only when you have a proportion and an equal sign. If I'm multiplying fractions, I just multiply all the numerators together, 3 times 3 times 3 times 3 times 3, There's 5 of them, 3 to the 5th power. And 4 times 4 times 4 times 4 times 4. There's 5 of those, 4 to the 5th power. So notice how the rule is, you take the numerator and raise it to that power, 3 to the 5th, and the denominator and raise it to that power, 4 to the 5th. So here are 2 examples, one easy and one more challenging. X over 5 to the 3rd power is x cubed over 5 cubed. And you can leave it like that if it asks you to leave your answer in terms of exponents. But if there is something simple that you don't need a calculator for, like 5 cubed is 5 times 5, which is 25, times 5 is 125. So you can simplify it if you want to, but this answer is perfectly acceptable. It shows the rule. All right, what about this one? This one's the slightly more challenging one. Now why? Because it's combining a few rules. You've got a fraction raised to a power. So you're going to raise that numerator, which is 2x squared to that power, and the denominator raised to that power. Now we're going to apply our rules that we learned in chapter 7.1. So the denominator is easy. Power to a power means multiply. That's why you get y to the 9th. But over here, I've got a product. I've got 2 times x squared to the 3rd power. A lot of people forget about that 2 in front there. Don't forget to raise that 2 to the 3rd power. So 2 to the 3rd power and x squared to the 3rd power. 2 to the 3rd power is 8. X squared to the 3rd power is 6. All right, let's do it. What's the matter? It's going to run out of time. Okay, that's the notes. I'll do another video because I think I'm going to run out of memory on the camera right now. So I'm going to stop there and I'll do the examples in another video.